This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's episode 722. This week we welcome Pete Consigli, John Isaacson, and the Z-Man, Cliff Zlotnick. Robert Concrete Bob Higgins, best practices for testing moisture in concrete substrates. It's the surface stupid. I love Bob, and I think he's been a real, he's a gem for people that are trying to figure out concrete issues. Cliff?
Yeah, he's also a genius, and I think he can talk way above a lot of people's heads. But, you know, one of the things he talked about was a lot of times we only think there are three phases of water: solid, liquid, and gas. And he said that there are two more that are important, which is absorbed water and then adsorbed water. He said that the pH of a floor is not relative to concentration. And he essentially had this example where he took this glass and he put in some, sodium carbonate, and then he measured the pH of it. And he took another glass, same amount of water, and he kept putting more and more sodium carbonate in there, and it didn't change the pH. I hope some people from the IICRC kind of watch that, because they just never get that. Some other things, he said that all concrete will eventually crack, curl, or warp. That plastic reinforcements used in concrete cause uniform cracking, that concrete deforms as it ages, that vapor pressure and hydrostatic pressure problems don't exist in concrete. Then he had this.
I got to stop you there, Cliff. That is the one that just blows people's mind. I get so much pushback from the CIH world and others on that whole topic. I just think that's something we're going to have to continue to explore.
And his citation for that is a 1965 article written by someone named Brewer, who established moisture migration of concrete slabs on the ground. And that was done by the Portland Cement Association. And one of the things Bob said was he's been in this industry for 40 plus years, and he's gaining knowledge, losing knowledge, and then having to regain it again. So I think what happens is the industry changes and the education changes. One cool thing was that if you took 1 square meter of concrete, it could actually hold 200 plus gallons of water. But to get that same amount of concrete to a 100% relative humidity, it only takes 2 ounces of water.
I think it was 90%, wasn't it? 90%.
I wrote down 100.
You might be right.
Either way, it's not a whole lot of water.
Yeah. Beside the fact, yeah.
Right. And then the other thing is critical humidity threshold. What happens is there are salts that are in the concrete and cement, and what happens is these salts play havoc if they're the wrong salts. Over to you, John.
Do I understand correctly? Like when you're drying wood, the layers kind of shed the water upwards, and in concrete, he's basically saying when it gets wet, it pushes the salts upwards, right?
I think they both come up.
Okay. Yeah. I think this presentation, both presentations prior were really excellent. This is the one that kind of woke up the audience. People were starting to, wait, what are you saying? And it just makes me, here in Washington, you can see Mount Rainier, and there's certain times when you can see it and you think, oh my gosh, I can finally take a picture that captures just how massive it is in our landscape. And then you take the picture and it's nothing like, what you're seeing in real life. And I think it just, even as we're recapping it, it's the importance of actually being in the room and being able, there was great dialogue, with the speakers and obviously high level people in the audience, and people that want to learn. I don't think I can really add anything to what Cliff said. One thing he did say, if you know what to ask for, they can't pull the wool over your eyes. And so a lot of what he was presenting was, don't just believe what we've always believed as convention, really test whether what you believe is is fact and plays out in the built environment when you're dealing with moisture.
He also did another presentation there, which we'll get into, where
Yeah.
he went deeper into some of these concepts and then added some new ones.
Yep.
And then I guess the next guy was Dr. Ralph Moon. Don't fall prey to MUS, which is either made up stuff, or if you're a scientist, made up science. And what I took away from him is that it's all about science. Every building material has science behind it. I talked about the scientific method, where you define a question, you conduct research, you propose a hypothesis, you can perform experiments to test the hypothesis. From that you get data and analysis, and from that you draw conclusions. One of the things I thought was fascinating is he had this slide of a piece of wood, and he talked about the different ways that wood could be cut, and that the manner in which they have the same log, the manner in which they cut that wood influences the amount of moisture resistance that wood's going to have, which I never really thought about before. And he pointed out that rift cutting that sawn wood is the most moisture resistant. And he said that we've known about this since 1919, when the Forest Products Laboratory of the U.S. Department of Agriculture conducted research on aircraft propellers. So those old double-wing planes from World War I,
wood propellers
were made out of wood.
Yep.
And then he talked about duration of loss, and he had done some experiments. He mentioned that OSB expands 30% in exposure to high relative humidity. Talked about window failure caused by OSB expanding around the window and creating pressure on the window and then making it leak. And he talked about, studying the elapsed time from leak to when it's noticed. A lot of people have a leak in their home. They don't recognize it. It can be from, refrigerator, water line going to the refrigerator for ice, or, something underneath the sink, and it's underneath the floor and it leaks for a long period of time before the people identify it. So he's done a lot of study on that. Over to you, John.
Yeah, that was, seeing, the simple tests that they put together to try to test different materials and the impacts of moisture and pressure. That was really interesting. And then his point to using the right materials in the environments. The flip side to that is, even if we have the data, still cost sometimes drives the materials that we use. So even if it's maybe subpar, it's not just the science, it's the market, and then educating the client on, why this costs more, but it is better in the long term, if the client even values that. So
looks like Bob Higgins, Robert Higgins, the concrete guy, was a busy man at the conference. He also did a session called "What You Need to Know About Inspecting and Drying Concrete. How wet is it? When is it dry? And why citations are important to back up the facts." Cliff?
He gave a very interesting case study, and this case study occurred out in San Diego at the Del Coronado Towers. And he was brought in, and this was a huge litigation going around and around. And one of the issues dealt with industry standards. And Bob knew a lot about both the technical side, and he had experience in industry standards. And what happened was, Bob recognized that what this contractor was supposed to have been deficient in doing, according to a standard, that the standard did not exist when the contractor did the job. And at that point, his side, won the litigation, and contractor was off the hook. And I thought it was, pretty cool situation there. Okay, other notes. Let's see. Understanding moisture analysis of what's actually in the cement or concrete, that calcium hydroxide plus sodium chloride or salt improves water solubility. He said a measurement of moisture in concrete is not a conclusion. You need to find out the how and the why that's causing that measurement. he talked about how relative humidity probes measure relative humidity in a floor. You actually bore these holes in, and then what happens is they put in a humidity probe, and it's airtight. Within that hole that's drilled in the cement, and that's how actually they can determine how much moisture is in the cement. Said that nearly all surface coating failures on concrete are created by moisture within the top 3/4 of an inch of the concrete. He mentioned that heat interferes with the formation of cement. And a lot of times, if you're in a cold weather area, they add antifreeze. Sometimes they add ice melt, calcium chloride in order to it. That calcium chloride generates heat, and they may not think about it, but that heat actually can adversely affect the cure. He said that higher alkalinity in concrete means that it's going to have higher resistance to drying. And finally, that concrete is notoriously inconsistent. So different parts of that floor are going to have differences in aggregate, size and shape, and chemical composition. Over to you, John.
I think he made the point a couple of times. The way most people test is they abrade the surface and then come back in 24 hours. And his big point was, if you want to get an accurate reading, get a reading first as is, abrade the surface, and then I think it was within a half an hour, wasn't it, Cliff, that then take your secondary reading to determine what the moisture is. Because if you wait that full 24 hours, it's just pulling moisture from the environment as opposed to moisture from the slab itself. And then I think he said it several times, is losing the basics, chasing the argument, where basically you come to the site with an assumption, and then you're just looking for that assumption rather than allowing the site to speak.
All right. So the next one is Howard Woodie Brickman and John T. the Roof Guy Hall, From the Floor to the Rooftop. Howard did an introduction to wood science technologies, evaluating job site conditions, sourcing and working with craftsmen, and what to expect in a subcontractor relationship. And then John did best practices for commercial roof inspections using a moisture locating technologies and how to interpret the readings to spot false negatives. Cliff?
Okay, let's do Howard, I guess, first. He talked about the fundamentals of basic science and the need for meaningful observations. And he gave a couple of reference books, one of which was written by Isaac Asimov. Actually, he actually
Wow.
was taught physics, and another one was written by a fellow by the name of Bruce Hodley, and that was Understanding Wood and Identifying Wood. He said that regurgitating bad information is not an effective strategy. He complained about professionals who did not use technical terms correctly. And then he said he's not a believer in the C word. And for him, the C word is consensus. And he talked about how they come up and compromise, and that really we should be uncompromising. Is something, it either is or it isn't. It's not this gray area of compromise, that's in between. He talked about magic words. He said that wood either shrinks or swells.
Yeah.
And he talked about, using the correct terms: cupping, concave, crowning is convex, what is tangential, what's longitudinal, coniferous, deciduous, growth rings, early wood, late wood, rings, porous and diffuse porous. He said that absence of evidence is not evidence of absence. He said that trees grow and wood flooring shrinks and swells. He said there's a difference between what happens with a tree and what happens with wood. One of the big takeaways was wood flooring is not a living, breathing thing anymore. There's no live cells in that wood. John, go ahead. I've got a few more, but go ahead. We're trying to conserve a little time.
You stole most of my damn notes. Other than I think he said, I think he literally said fear is what drives consensus, which was fun. So I'll leave it at that.
Well, let's move on. Let's move to Kelvin Rynhart and Ryan Stanley, an update on cloud-based moisture testing technologies and software integration for the Tramex monitoring system. We did a show on that not too long ago, actually, Cliff.
Okay, with Kelvin and Kelvin Rynhart, Ryan Stanley. What they talked about was their remote monitoring system, the utilization of multiple sensors, and that the sensors need to be labeled correctly by location. And he said that there's resilience in remote monitoring. In their case, they have in-house recording, so that in the event that there's a power failure or battery failure, they're still going to be able to have data. They're adding additional meter readings to their software and building it into their monitoring systems. They're talking about integrating their system with dehumidifiers and integrating it with report writing systems. And I said that there's a need for a full toolbox.
John?
Yeah, that yep, I think all the integration too, they integrate with all the reporting systems, was piggybacked on what Josh was talking about.